Good morning, students. Welcome back to chemistry class. Today we are going to study about empirical formula and molecular formula. Okay. Page number 10, unit number 1, page number 10, up to the gram equivalent mass, gram equivalent concept we completed. And today we are going to study the empirical formula and molecular formula. Okay, empirical formula. How can you calculate the empirical formula and molecular formula of different compounds? Okay, we are going to study. Listen carefully, take notes. Okay. Empirical formula and molecular formula. The elemental analysis of a compound gives the mass percentage of atoms present in the compound. Using the mass percentage, we can determine the empirical formula of the compound. Using the mass percentage, we can determine the empirical formula of the compound. The molecular formula of the compound can be arrived at from the empirical formula using the molar mass of the compound. Molar mass means molecular mass. The molecular formula of a compound can be determined from the empirical formula using the molar mass of the compound. We can determine the molecular formula of the compound using molar mass. Okay, we can determine the molecular formula of the compound from the empirical formula using molar mass of a compound. Understood? So, the empirical formula means it is the simplest ratio of the different number of atoms, the different atoms. Empirical formula of a compound is the formula that is written with the simplest ratio of the number of different atoms present in the one molecule of the compound. Okay, so molecular formula we know. Molecular formula means the actual number of different atoms present in the one molecule. Actual number of atoms. For example, acetic acid means, what is the molecular formula? CH3COOH. Okay, this is the molecular formula acetic acid. This is the formula of the acetic acid. The molecular formula we can write how much carbon atoms are having here. 2 carbon atoms. So C2. How many hydrogen atoms are having? 3 plus 1 4. So C2H4. Oxygen 2O2. This is the molecular formula. So this is C2H4O2. This is the molecular formula of acetic acid. So molecular formula means the actual number of different atoms present in one molecule. Understood? So the empirical formula means the simplest ratio. Okay. So this is molecular formula acetic acid, C2H4O2. So how we can determine the empirical formula? Simplest ratio. Okay, so C2H4 by dividing by 2, we get C2 carbon 2 atoms. So 2 by 2 we get 1. Hydrogen, 4 hydrogen atoms. So 4 divided by 2 we get 2. Oxygen, total 2 atoms. 2 divided by 2, 1. So ratio of the carbon is to hydrogen is to oxygen is 1:2 and 1. Okay, 1:2:1. This is the ratio. So it is called. So actually the ratio is 1:2:1. So hence the molecular empirical formula is carbon how much? 1. So C, hydrogen 2. So H2, oxygen 1. O. Okay. So this is the difference between molecular formula and empirical formula of acetic acid. Understood? Okay. I hope all of you understood about that. Now we are going to determine the empirical formula from the elemental analysis data. How we can determine the empirical formula. Okay, here the 4 steps are given. What is the step 1? The step 1 means first step, since the composition is expressed in percentage, we can consider the total mass of the compound as 100 gram. 100 gram. Okay, total mass we can consider as 100 gram. This is the step 1. Step 2. What is the step 2? Divide the mass of each element by its atomic mass. Divide the mass of each element. Okay, the mass is given. Divide the mass of each element by its atomic mass. This gives the relative number of moles of various elements of the compound. Relative number of moles we get by dividing the atomic mass with the mass. We get the relative number of moles of various elements. Okay. What is the step 3? Divide the value of relative number of moles obtained in the step 2 by the smallest number of them to get the simplest ratio. Okay. So when we are dividing the mass of an element by its atomic mass, we get a relative number of molecules. Relative number of moles we get. Okay, so divide the value of relative number of moles obtained in the step 2 by the smallest number. Okay, by the smallest number of them to get the simplest ratio. What is the step 4? In case the simplest ratio obtained in the step 3 are not whole numbers, suppose it is not in whole number. Okay, we get the simplest ratio. The simplest ratio, suppose it is not in whole number, then they may be converted into whole number by multiplying a suitable smallest number. Multiplying the suitable smallest number. Which number we are dividing, we get the whole number, that is the simplest small number. Okay, understood? So this is the four steps to determine the empirical formula. Okay, so we can discuss this one by one. Okay, with the example. First step on example 1. Example 1. An acid found in tamarinds on analysis shows the following percentage composition. What are the composition? 32% carbon, 4% hydrogen, 64% oxygen. Find the empirical formula of the compound. Find the empirical formula of the compound. Okay, first what is the example 1? 32% carbon, 4% hydrogen, 64% oxygen. Okay, find the empirical formula. Here, what are the different atoms given? Carbon, hydrogen and oxygen. Okay, what are the elements? The elements are carbon, hydrogen, oxygen. And what is the percentage? What is the percentage given? 32. Carbon 32%. Carbon how much? 32. Hydrogen 4. And oxygen 64. Okay. And what about the molar mass? You know carbon. What is the molar mass of carbon? Molar mass or atomic mass? What is the mass of the carbon? 12. We know. Hydrogen 1. Oxygen already we know. Oxygen 16. Okay. What is the relative number? How we can calculate the relative number of moles? How we can calculate the relative number of moles? See the step 2. How we can obtain the relative number of moles? Divide the mass of each element by its atomic mass. Okay, so this is the mass. Carbon 32, hydrogen 4, oxygen 64. This is the mass. Okay, by dividing the mass by the atomic mass, we get the relative number of moles. Okay, so here for carbon percentage, what is the mass of the carbon? 32%. So 32 divided by molar mass 12. So when we are dividing 32 divided by 12, we get 2.66. This is the relative number of moles of carbon. Then hydrogen. Hydrogen, how much percentage? 4. 4 divided by what is the molecular mass of hydrogen? 1. 4 divided by 1, we get 4. Okay. Then oxygen, percentage 64. What is the molar mass? 16. So what is the relative number of moles? 64 divided by 16 we get. And we are dividing the 64 by 16. We get 4. Okay. And what is the simplest ratio? How we can obtain the simplest ratio? According to step 3, divide the value of relative number of moles obtained in the step 2. Okay, divide the value of relative number of moles obtained in the step 2. Step 2, we get a relative number of moles. Okay, so divide the value of relative number of moles obtained in the step 2 by the smallest number of them. Okay, we get what is the relative number of moles for carbon? 2.66. Hydrogen 4. Oxygen 4. Which one is the smallest number? Carbon. Carbon 2.6. This is the smallest number among them. Okay, so what is the third step? Divide the value of relative number of moles obtained in the step 2 by the smallest number of them to get the simplest ratio. Understood? So we get 2.66 is the smallest number. So how we can get the simplest ratio? 2.66 divided by 2.66 is equal to 1. For hydrogen, 4. Okay, relative number of moles 4. So smallest number among the 3 elements, which one is the smallest number? 2.6. Okay, so we can divide the 4 divided by 2.66, we get the 1.5. When we are dividing 4 by 2.66, we get the 1.5. Okay, so suppose oxygen, what is the simplest ratio? 64 divided by 16, relative number of moles 4. Relative number of moles 4. Simplest ratio 4 divided by 2.6, because 2.66 is the smallest number. Okay, 2.66 is the smallest number. So 4 divided by 2.66, we get the 1.5. Okay. Then how we can get the simplest ratio in whole numbers? Okay, this is not in whole number now. The simplest ratio now it is not in whole number, because the carbon simplest ratio 1, but hydrogen 1.5. This is not in whole number. Oxygen also 1.5. It is not in whole number. Okay, so how we can get the simplest ratio in whole number? According to step 4, in case the simplest ratio obtained in the step 3 are not whole numbers, then they may be converted into whole number by multiplying by a suitable smallest number. Okay, so how we can get the smallest number? We can get the whole number by multiplying the smallest number, suitable smallest number. By multiplying suitable smallest number, we get the simplest ratio in whole number. Okay, so here this is whole number. This is not a problem, but this is 1.5. It is not a whole number. So when the simplest smallest number, when we are dividing this, 1 is the smallest number. Okay, so when we are 1.5 into 1, we get the 1.5 same value. So another one smallest value 2 is another one smallest value. So when we are multiplying 1.5 into 2, we get 3. Okay, this is the smallest number. Okay, so for the 3 elements, for each element, we should multiplying 2 to get the simplest ratio in whole number. Okay, so carbon, when we are multiplying carbon, simplest ratio 1. When we are multiplying 1 into 2, we get the 2. Hydrogen 1.5 into 2, 3. Oxygen 1.5 into 3 into 2, 3. Okay, so this is the simplest ratio in whole number. Understood? So, what is our question? Determine the empirical formula. How we can determine the empirical formula? The mass percentage only given. Okay, from this data, we can get the empirical formula of the substance. Okay, so here the empirical formula is carbon, what is the simplest ratio? 2. So C2, hydrogen 3, H3 and oxygen 3, O3. This is the empirical formula of this substance. Okay, understood? And another one example. Example number 2. An organic compound present in vinegar, has 40% carbon, 6.6% hydrogen and 53.4% oxygen. Find the empirical formula of the compound. Okay, so this is the second question. This is the second question. An organic compound present in vinegar, has 40% carbon, 6.6% hydrogen, and 53.4% oxygen. 53.4% oxygen. Find the empirical formula of the compound. Find the empirical formula of the compound. Okay. So here, what is the element given? Carbon, hydrogen, oxygen. How we can get the empirical formula? 4 steps we can follow. 4 steps. What is the first step? What are the percentage given to the 3 atoms? First element name. You should write the element name. How much elements are having? Carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen. What are the percentage given? For carbon 40%. For carbon 40, hydrogen 6.6 and oxygen 53.4. Carbon 40, hydrogen 6.6 and oxygen 53.4. Atomic mass, you know, carbon, atomic mass of the carbon 12, hydrogen 1, oxygen 16. This is the atomic mass. Okay. And then we have to calculate the relative number of moles. Okay. So we should follow second step here. Divide the, how we can get the relative number of moles? Divide the mass of each element by its atomic mass. Okay. So carbon, what are the mass given? 40%. Okay. So when we are dividing the 40 divided by 12. Okay, 40% carbon given. So 40 divided by atomic mass what? Carbon 12. So 40 divided by 12. When dividing the 40 by 12, we get 3.3. 3.3. Okay. And secondly, hydrogen percentage given 6.6% in our question. Atomic mass of hydrogen, you know, 1. How can you get the relative number of moles? By dividing the mass by atomic mass. Mass is 6.6% divided by 1. We get 6.6. Then third one, oxygen. 53.4. Oxygen 53.4. Atomic mass for oxygen, atomic mass 16. The relative number of moles, when you are dividing the mass by atomic mass, we get the relative number of moles. So 53.4 divided by 16, we get 3.3. Okay. And then we should calculate the simplest ratio. How can calculate the simplest ratio? According to step 3, divide the value of relative number of moles obtained in the step 2 by the smallest number of them to get the simplest ratio. Okay, divide the value of relative number of moles obtained in the step 2 by the smallest number of them to get the simplest ratio. Okay, so here which one is the smallest number among the three elements? Relative number of moles, which one is the smallest? Carbon 3.3, hydrogen 6.6, oxygen 3.3. Among the three elements, for the relative number of moles, carbon and oxygen same value. These values are it is smaller when compared to hydrogen. Hydrogen relative number of moles for the hydrogen 6.6, but carbon and oxygen 3.3. Okay, so we can take 3.3 as the smallest number, smallest ratio. So when we are dividing the 3.3 by this three values, we get the simplest ratio. Okay, so for carbon atom, relative number of moles we know 3.3. So 3.3 is the small value. So 3.3 by 3.3. When we are dividing this, we get the 1. And 6.6 divided by 3.3, we get 2. Again 3.3, oxygen 3.3, relative number of moles 3.3. 3.3 divided by 3.3, we get 1. Okay, you see these three values are whole number. Okay, three values, it is whole number. Okay, no need to multiply, no need to convert the simplest ratio. Already it is in whole number, no need to multiplying with another number. Okay, so for carbon atom, what is the simplest ratio in whole number? 1. Hydrogen, what is the simplest ratio in whole number? 2. Oxygen, what is the simplest ratio in whole number? 1. Okay, so what is the empirical formula of this substance? Carbon 1, C, hydrogen 2, so H2, oxygen 1, so 1. O, okay, CH2O. This is the empirical formula of this compound. Understood? Okay, and one evaluate yourselves are having in your textbook how to do as the homework. Okay, understood? And then next topic, calculation of molecular formula from empirical formula. How we can calculate molecular formula from empirical formula. Okay, so here one of the expression is given. You know, the molecular formula of a compound is a whole number multiple of empirical formula. Okay, so molecular formula, how we can calculate the molecular formula? It is one of the whole number multiple of empirical formula. Understood? The molecular formula of a compound is the whole number multiple. Okay, we can when we are multiplying the empirical formula with the whole number, we get molecular formula. How we can get the whole number? The whole number can be calculated from the molar mass of the compound. Whole number, how we can calculate the whole number? Whole number we can calculate from the molar mass of the compound using the following expression. Okay, whole number, you know, whole number means n, the symbol of the whole number small n. This small n is equal to molar mass of the compound. What is the formula to calculate the whole number? Whole number n, it is equal to molar mass of the compound divided by calculated empirical formula mass. Okay, molar mass of the compound by calculated empirical formula mass. Okay, and we are dividing the molar mass by calculated empirical formula mass, we get the molecular formula. Okay, understood. So we get the whole number. When we are multiplying the whole number with the empirical formula, we get the molecular formula. Understood. So for example, one of the table given, first one, compound. The compound name, acetic acid. First compound, acetic acid. What is the empirical formula acetic acid? We know acetic acid structure CH3COOH. This is the structure of acetic acid. What is the empirical formula of this acetic acid? How we can calculate the empirical formula from molecular formula? So what is the, this is the structure. Okay, so what is the molecular formula? How many carbon atom having? C2, hydrogen 4, oxygen 2. Actually this is molecular formula, we know already, we learned. Okay, so how we can get the molecular formula? This molecular formula, how we can get? That is, now we are going to study. Okay, so empirical formula, you know, this is the simplest ratio. Okay, so this is the molecular formula. Empirical formula means simplest ratio. That is carbon 2 means hydrogen 4 and oxygen 2. When we are dividing 2 with this both 3 atoms, we get the simplest ratio. When you are dividing carbon 2 by 2, we get the carbon C. Hydrogen 4 by 2, we get the 2. So CH2O. Okay, we know this is the empirical formula for the acetic acid. What is the molar mass? Molar mass means total molar mass of acetic acid. Acetic acid, you know, CH3COOH. What is the molar mass? When we are adding this atomic mass of this each element present in this compound, we get the molar mass. When we are dividing, when we are multiplying and adding. Okay, so carbon, how much carbon? 2 carbon. So carbon, what is the atomic mass of carbon? 12. So 12 plus hydrogen 4. Okay, 12 plus 4 plus oxygen 16. 16 into 2, we get the 32. Okay, when we are adding this all, we get the molecular mass. Okay, this is the molecular mass. So empirical formula of the empirical formula mass means empirical formula what? CH2O. What is the empirical formula mass? So this carbon 12 plus hydrogen 2. Okay, 2 into carbon atomic mass 12, hydrogen 1. So how much hydrogen are having? 2. 2 into 1 is equal to 2. So 12 plus 2 plus oxygen 16 plus 16, we get the 30. This is the empirical formula mass. Okay, so whole number. So compound name acetic acid, empirical formula CH2O for the acetic acid, and molar mass 60, and empirical formula mass 30. 30. How we get the whole number? Whole number n. Whole number n means, what is the formula to calculate the whole number? The whole number is equal to molar mass of the compound, molar mass of the compound by calculated empirical formula mass, calculated empirical formula mass. Okay, when we are dividing these two, we get the whole number. Okay, so molar mass, you know, 60 divided by empirical formula mass 30. 60 divided by 30. When we are dividing 60 by 30, we get the 2. Okay, you know. So how we get the molecular formula? Multiplying the empirical formula with the whole number. Multiplying empirical formula with the whole number, we get the molecular formula. Okay, CH2O into 2. Empirical formula acetic acid CH2O. So whole number 2. So CH2O into 2, we get the C2H4O2. So carbon 1 into 2, 2, C2. Hydrogen 2, 2 into 2, 4, H4. Oxygen 1 into 2, 2. Okay, C2H4O2. This is the molecular formula. Okay, this is the way to calculate the molecular formula from empirical formula. Another one example, hydrogen peroxide. Hydrogen peroxide. Hydrogen peroxide, you know, H2O2, okay, hydrogen peroxide. What is the empirical formula? HO. Okay, empirical formula for the hydrogen peroxide, HO. 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 Okay, so molar mass of the hydrogen peroxide 34. Molar mass 34. When we are adding all the atomic mass of the each and every element present in the compound, we get the molar mass. Okay, so molar mass 34. Empirical formula mass 17. Okay, when we are adding these two atomic mass of these two, we get the empirical formula mass, that is 17. 16 plus 1 hydrogen 17. So what is the whole number? What is the formula to calculate the whole number? Whole number N is equal to molar mass of the compound divided by calculated empirical formula mass. Okay, molar mass 34. So 34 divided by 17 is equal to 2. What is the molecular formula? When we are multiplying the empirical formula with the whole number, we get the molecular formula. Okay, so empirical formula HO into what is the whole number 2, we get the H2O2. Hydrogen 1 hydrogen 1 into 2 H2, oxygen 1 into 2. Okay, and then lactic acid. Lactic acid. Lactic acid, what is the empirical formula? CH2O. Empirical formula CH2O. Molar mass 90. Lactic acid molar mass 90. Empirical formula mass 30. Empirical formula mass what? 30. Okay. So whole number molar mass by empirical formula mass 90 divided by 30, we get the dividing 90 by 30, we get 3. Okay, so empirical formula CH2O, whole number 3. When you are multiplying empirical formula with whole number, we get the molecular formula. CH2O into 3, carbon 1 into 3, 3C3, hydrogen 2 into 3, 6, oxygen 1 into 3, 3. So C3H6O3. Then tartaric acid, another one example, tartaric acid. Tartaric acid, empirical formula C2H3O3. C2H3O3. What is the molar mass? 150. Molar mass of the tartaric acid 150. What is the empirical formula mass? 75. 75 empirical formula. This is the empirical formula when we are adding and multiplying all the atomic mass of each and every element present in the empirical formula, we get the empirical formula mass, that is 75. What is the whole number? Molar mass divided by empirical formula mass, we get the whole number, that is 2. Okay, so what is the molecular formula here? When we are multiplying the empirical formula with whole number, we get the molecular formula. Empirical formula C2H3O3. C2H3O3 into 2, we get the molecular formula C4. 2 into 2, 4, C4. Hydrogen 3 into 2, 6. Oxygen 3 into 2, 6. Okay, C4H6O6. Then benzene. Another one example, benzene. Empirical formula for benzene, CH. Molar mass of benzene 78. Molar mass what? 78. Empirical formula mass 13. Empirical formula mass 13. Okay, and what is the whole number? When we are dividing the molar mass by empirical formula mass, we get the whole number. 78 by 13, we get the 6. Okay. What is the molecular formula? When we are multiplying the empirical formula with the whole number, we get the molecular formula. CH into 6, we get the C6H6. Carbon 1 into 6, C6. Hydrogen 1 into 6. Okay. Understood? These are about the calculation of empirical formula. Understood? So, everyone please study. Okay, students, today your assignment, two questions are given as assignment. First, page number 11, evaluate yourself question. Okay, right answer of the page, evaluate yourself. A compound and analysis gave the following percentage composition: carbon 54.55 percentage, hydrogen 9.09 percentage, oxygen 36.36 percentage. Determine the empirical formula of the compound. Okay, I have to do this problem by you can refer two examples we studied. Okay, you refer these two examples and do this problem. Okay, and page number 12, I'll have to take page number 12. The one problem is given here. The empirical formula same for the acetic acid and lactic acid. This empirical formula same, but molecular formula different. How? You can calculate the molecular formula of acetic acid, that is vinegar, and lactic acid, that is the sour milk. You know, the acetic acid means vinegar means acetic acid, sour milk means lactic acid. Okay, but here for the vinegar, molar mass 60 gram per mole, but sour milk 90 gram per mole. Okay, 90 gram per mole. This is the molar mass different, but empirical formula same. Both vinegar and sour milk, empirical formula same, that is CH2O. Okay, so how can you calculate the molecular formula? You refer this example and do and write and send me through my WhatsApp number. Thank you, students. Thank you.